Welcome and thanks for joining us for this episode. We're going to be talking today about internet protocol numbers, as well as some traffic types that you'll need to know. And some of these internet protocol, maybe not the numbers, but the names might be familiar to you. The numbers were totally new to me. So might be some flashcard material, but it is good to know. So where would you like to start?
Yeah, I think I want to go ahead and start with what the heck is an IP protocol number, right? Because we've had episodes, and you can check them out. We've had episodes on port numbers for protocols and stuff like that. So why do we have these IP protocol numbers even? Well, I want you to think about something. You know, when we talk about port values, let's talk about a common one. Like, in fact, Sophia and I were just mentioning this beforehand. You know, when you spin up a web server, and let's say you don't... Rarely today do you need unencrypted web traffic, but I'm just for the sake of conversation, you spin up a web server, and instead of putting it on port 80, which is the well-known port for port value for HTTP, you decide to do what a lot of people do. You kind of obscure it and maybe do 8080, right? Well, you've now changed the port value, right? And that is something that you can modify. You can modify the port value, but what if you needed to craft a firewall rule, right? Well, I can modify the port value. Right, and then I could potentially bypass your rule, unless you have stateful packet inspection and the application layer firewalls. They can actually look at the data and they can see. So, would it be nice to have maybe a method in which you can craft these firewall rules around something that somebody can't change? Now, that's not why these were invented, but I can give you a scenario where that is a scenario where they would be utilized. These protocol identifiers, very basically, what does that mean? We have an IP packet, right? In that IP packet, you have the IP header, and in the IP header, you have the source and destination address. Well, inside of that header, you also have an IP protocol ID number. So what does it do? Well, if you've watched, and if not, I encourage you, if you've watched our episodes on the OSI model, one of the things that we say is as abstractly the protocol data units get passed down and they provide their services through the layers, I have said that lower layers aren't really aware of what's going on at the upper layer, and upper layers don't. That's the beauty of it. They don't have to be aware of what's going on down in the lower layer. They just have to know what's going on at their layer. Well, that being said, there are ways that we can tell IP, this is the protocol that your upper layer data is wrapped in. So we know how to handle it at the network layer. The other benefit of that is now we can craft firewall rules that aren't associated just with a port value. They're associated with something that is built into the network stack and assigned by uNeY. Right, we've talked about internet standards bodies, right? That's the Internet Assigned Numbering Authority. They were out there before ICANN, right? Today, they still provide the same function, but they're overseen by ICANN. That's uNeY that sets these. You cannot change these, and that's one of the reasons they're really good for crafting things like firewall rules.
Okay, so we've got some of these ones we're going to go through. I know there's a whole list of them that exist somewhere, but we're just going to talk about some of them today. And I think as good a place to start as any. Can we start at number one?
Yeah, absolutely. And I did the first couple of them. You're going to see they kind of go in order, but then after that they don't. And that's because there is a long laundry list of these protocol or IP protocol numbers that uNeY has maintained. Some of the common ones are right here in this list. If you would like to shorten this episode, I encourage you. Just go ahead and pause the video, make you some flashcards. So if in the IP header you have a number one IP protocol number, that is letting IP know that the upper layer protocol, it was wrapped in ICMP, the Internet Control Message Protocol. The other one we have here is IGP, that's number two, Internet Group Management Protocol, get our acronyms right. That's how we orchestrate multicast communications. That's the protocol that does that, and that is, well, protocol ID number two. Now, there are a couple that we're going to go ahead and talk about, Transmission Control Protocol and UDP, because they are at the same layer and kind of juxtaposed against each other in what they provide. Remember, Transmission Control Protocol, reliable protocol, connection-oriented service, will rebuild your data and provide error correction, detection and correction, right? But the port or the ID number for that is going to be 6. UDP, on the other hand, the User Datagram Protocol, best effort delivery, very stripped down transport protocol, highly optimized and fast, but doesn't do error recovery. That is going to be 17. Now, There are a couple more here. I'm going to have Sophia help me with one. Can you do me a favor in the background, since I am so studious? I did not put GRE's number up there. So if you can help me out with that, I'll go ahead and explain some of these other ones while she's got my back on this one. So AH is the authentication header, and ESP is the encapsulating security payload. These are the two protocols. Two of a larger suite called IPsec. IPsec is a suite of security technologies that we implement on IP, because IP inherently is insecure. All right, well, when that traffic needs integrity but doesn't need encryption, we use authentication header, and that is ID number 51. Be very careful. I don't want to confuse you on that one. The encapsulating security payload we can apply to our data when not only do we need data integrity, right? We need to know that the data hasn't been modified, we know who it came from, but we also need to encrypt the payload. We're going to encrypt it with the encapsulating security payload, or ESP. These are the two prime protocols inside of IPsec, or the Internet Protocol Security. I would be aware of them. Now, without further ado, do you know what that GRU? I almost said GRU for our local power company here. GRE, the Generic Routing Encapsulation Protocol.
According to the website that I am pulling this from, it says it is number 47.
All right, so we are going to finish. Thank you for finishing my work here. You said 47. All right, so again, these numbers are kind of set in stone. It was uNeY that came out with them. These are some of the more common ones that I would definitely want you to kind of get your hands on and know what they are. At the end of the day, it's flashcard material. What I want you to be able to understand is that these tell IP the protocols at the upper layer that are servicing or wrapping the data.
Now, I know we're going to talk about some traffic types in this episode as well, but before we move on from these IP numbers, the website that I pulled it from was the uNeY.org website. So is that where you got all this information?
Most definitely. And I went ahead and put that in the show notes for you all so that if you wanted to look at it, you can. They're not all exam material. They're not all going to be useful in a help desk support scenario. Some of them don't even exist anymore, because you got to remember, uNeY's been around since the days that it was called the DoD stack, not TCP/IP, so going back to the 70s. But if we take a look, you can see that they do still update this. Let me go ahead and zoom in here for you. Notice that it said last updated. Well, that was last month, right? Or that's this month. We're still in January, aren't we?
Crazy.
Oh my gosh. So it was, thank you. So it really does read just like an RFC, right? That's the request for comment. Two different bodies here. One is IDF, the Internet Engineering Task Force. They're the ones that oversee, this is going to be, they oversee the RFC. They're the ones that control and monitor the RFCs. uNeY controls these numbers. Notice it says the Internet Protocol version 4. There's a field called a protocol to identify the next level protocol. And that's what it does. It just helps to identify, in a nutshell, what those upper level protocols are. And if we kind of just scroll down, I don't want to get you all seasick here, but you can see there are a ton of them, right? And if I was to do maybe a control F here and I was to look for 51 and hit enter, we go through this a couple of times. Yeah, there it is. And notice I see AH and ESP right there. And these are, volunteers, and some of them are directly related to the Internet Engineering Task Force request for comment. So remember, when we talk about standardization, these are the standardization bodies. And at the end of the day, if you want to study for something that might be on an exam or something for your support desk roles, remember to go to the source. It's always good to know where that information came from.
So the traffic types that we mentioned at the beginning of the episode, I think there's a handful of them we're going to talk about. And one of the ones that was listed was broadcast. And I hear broadcast and I think like broadcast news, like a TV channel. So am I on the right track there?
Yeah, you absolutely are. So we have a few different types of communications. Talking about the very first one, broadcast. Broadcast is a communication that is kind of like standing up in the food court, standing on the table and yelling at the top of your lungs, all right? Now, what we describe it as is a one-to-one communication, kind of like Sophia and I are. If we just said, you know what, we're not going to include you in the conversation, and we're just going to have a conversation, not only would we be antisocial, but we would have would be having a unicast communication, right? Now, a multicast communication, what is that? Well, there's a couple different ways you can think of it. One of the ways that we kind of just generically mention it is that it is a one-to-many communication, not all. Many. A little bit difference now. Now we're not antisocial. We're talking to, Sophia and I are talking, but we're also talking to you, those of you that have a subscription with ACI. Guess what? If you don't have a subscription with ACI Learning, you're not a part of this conversation, right? Just like a pay-per-view event. A one-to-many is typically a group. Remember, multicast communications, we talked about IGMP. IGMP announces, I have a multicast group. Do you want to join it? When you join that, the only people or nodes, devices on the network that receive those communications are those devices that are part of those groups, right? It's a more efficient way than doing the broadcast. The broadcast is one to all. And I don't know if I said that right. I just want to make sure I said it right. Unicast is a one-to-one communication. That's like when I say, I need this file from a file server. I'm talking directly to the file server one-to-one. But if I come online and say, hey, anybody out there got an IP address? I need one. That's a broadcast. I told everybody on the network that I need an IP address. Well, guess what? There is one server on that network that's going, oh, I got that. Okay, you told everybody, but I'm the DHCP server. Here's your offer. Right? So the DHCP protocol starts with a broadcast communication. Lets everybody know on the network I need an IP address. Now, once the offer is made, after that, now I'm just going to talk directly to the DHCP server. Now it's a unicast communication. So that's your broadcast, one to all, standing up on the table, screaming at the top of your lungs in the food court, everybody hears it, which can be problematic. It's good in the fact that, I don't have to worry about routing or where the traffic needs to go to. I yell it to everybody and somebody's going to go, oh yeah, I was listening, right? So it's simple, but it can cause commotion, right? So I say I jumped up on the table and I screamed at the top of my lungs and I'm screaming. Sophia does that, somebody else does that. Pretty soon what you have is a lot of congested communications and it causes problems on your network. Multicast communications, they're more efficient because it only goes to the people that are in that group. I will tell you in IPv6, this is something that I would want you to know. IPv6 eliminates broadcast communications. Another thing I want you to know about this traffic type is that broadcast communications are segmented by routers. All right, if I have two switches in the same LAN operating and a device sends a broadcast into the switch, it's going to send that broadcast to the next switch, which is going to send that out all devices. It's within a broadcast domain. But when that signal that went to everybody hits the interface of the router filters it out. Routers do not pass broadcast communications, and that makes them a little bit more efficient at what they do, right? We don't need unnecessary information going to another network when it was just bound for everybody in this network. So I do want you to be aware of that. The last one that we have gets a little confusing here, Sophia. So we've got our one-to-one, right? We got our one to everybody, right? We've got our one. I like to say in a multicast, I say one to a group. It's one to many is how we say it, but I like you to remember one to a group because it's a multicast group. Right. That's right. The last one is Anycast. Oh, in unicast, if I didn't say one-to-one. Anycast is a one to the best, right? So we can say, hey, anybody out there, I need a path to that DNS server. Who's the best path? I didn't ask everybody. I just asked typically a router. Who's the best alternative? So that's a one to the best, right? And a lot of times we'll use that in, like, for instance, in DNS, finding that local DNS server rather than sending that DNS query halfway around the world to another server when we can really just send it locally, So that's the one to best. So going back down the list, let's make sure we got them all and we understand broadcast is one to all, multicast is one to a group or one to many, unicast is one to one, and Anycast is one to the best.
Okay, so we went through 4 of these, and these are the only 4 traffic types we really need to know, right?
That's right.
Whereas with the IP numbers, there is a whole list, but we went over the ones that are, I guess, more common.
I think they're more important, yeah.
Okay.
Absolutely.
Okay, those are the ones that we'll probably encounter more often then. So definitely some flashcard material, but I'm glad we got to go through it in a little bit more detail and talk about each of these. So thank you for walking us through that, Wes, and thank you for joining us, and we'll see you next time.